Welcome to EDU World Space.
In this problem, weights of each light is given in this in the problem, and that is weight of the light of A and weight of B is 4.1 pound, while the weight of C is 3.5 pound, and we have to find the point of application of the resultant equivalent force that will cause the same effect that these systems are causing. So basically what we have to do, that let's say this is our rod, where at the point A one force of 4.1 pound is acting, at point B another force of same magnitude is acting, 4.1 pound, and at point C the third force of magnitude 3.5 pound is acting, and we have to replace this system by an equivalent system where a equivalent resultant force should act from the point D. So let's say this was the point D, so its distance is, let's say, D, and in the first problem they have provided the distance small d and the value of d is 25 inches for the first case. So we are solving here the first problem, and so we can equate the forces in these two systems. So this was the real system and this is the equivalent system. So by force balance in vertical direction, R comes out to be 4.1 plus 4.1 plus 3.5 pound, and it comes out to be 11.7 pound. Alright, now for the calculation of the position or the point of application of this equivalent force on the line DE, for that we can balance moment about any point. Let's say we are going to consider the moment about point D. So if we calculate moment about point D in first case, so it will be, since it is at a distance of 10 inch, so moment because of this 4.1 pound force will be 4.1 multiplied by 10 in clockwise direction. So I am considering here clockwise to be positive. So we can choose anti-clockwise to be positive. It is not going to affect our result. And the second term, so its distance, perpendicular distance will be 34 plus 10, that will be 44. So 4.1 multiplied by 44, again this will cause the clockwise couple, and the plus 3.5 multiplied by its distance 44 plus this distance D is given as, in first part, 25 inches. So it comes out to be 69, and this must be equal to the moment caused by this equivalent force about the same point D, and that will be R multiplied by D. Value of R we have calculated here, so we can get the value of D, which comes out to be 4.1 multiplied by 10 plus 4.1 multiplied by 44 plus 3.5 multiplied by 69 divided by R, and which is 11.7. So if we solve this, it comes out to be 39.6 inches. 39.6 inches. Now in second part, they are asking the value of D, that is what should be this distance D, so that what should be the value of D so that the equivalent force or the resultant force passes through the midpoint of the section DE. Since DE, so we can draw it here. It will be a bit easier to understand the scenario what they are asking. So in second part, they are saying that this was D and this was E, and this 4.1 pound force is acting at point A, another 4.1 pound force is acting at point B, and the third 3.5 pound force is acting at point C, and they are asking to find the distance, and that is the distance between B and C, that is small d, in such that the resultant force passes through the midpoint of the line DE. Since length of the DE is 84 inch, it means that the point of application of this force from the distance, this distance should be 42 inches. Now, this is our equivalent system. So in equivalent system, if we balance the force, so R comes out to be summation of all these forces. So we can get the value of R, which will be 4.1 plus 4.1 plus 3.5 pound, and which comes out to be 11.7 pound. Obviously no other force, no extra force is going to work here. That's why the same result of the previous part will be here. So the resultant resultant force will be 11.7 pound. Now if we talk about the moment that is about point D, so moment about point D will be, since this is fixed point, its distance is fixed and that is 10 inches, so it will be, moment will be 4.1 multiplied by 10 plus moment because of the second force, that will be 4.1 multiplied by 10 plus this distance was, we can see here in the diagram, that was 34 inches, so plus 34, and plus moment because of this 3.5 Newton, that must be 3.5 multiplied by 44 plus D, and this must be the this must be equal to the moment because of this equivalent force, that is 11.7 multiplied by 42. So if we so here in this equation there is only one variable, that is D, and we can get its value. So D comes out to be, if we solve this, 33.1 inches. So this comes out to be 33.1 inches. So in first part we got the distance should be 39.6 inches. So the equivalent resultant force will pass at a distance of 39.6 inch from the point D towards the right side. And in second part our answer is 33.1 inch. It means that if the distance between the force B and C is 33.1 inch, then the equivalent force system, if we draw it, then it will pass through the midpoint of the section D